solve this problem, you'll be told an artist has 5 green, 7 blue, and 3 red crayons of the same size and shape in a bag. If he picks 2 crayons at random without replacement, find the probability that the 2 are of the same color, no red is picked, a blue and green in that order. So, for you to determine this probability, you must construct a tree diagram without replacement, isn't it? Are we together? So here, you can come with a key and you say, you let G to represent green, isn't it? So in your key, you can say, let G to represent green, and B to represent blue, and R to represent red, so that when 2 are picked at random, then you know that is independent, isn't it? Meaning the first pick, then the second pick. So you come here and say, this is our first pick. So in the first pick, when it's going to pick inside this bag, it's going to pick either green, blue, or red, isn't it? Are you seeing that? If he dips his hand in this bag, it's going to pick either green, blue, or red. But what is the total in this bag? 5 green plus 7 blue plus 3 red, we have a total of 15. We have a total of 15, isn't it? So for this given artist to pick a green is 5 out of 15, meaning picking a green is 5 out of. Then picking a blue is 7 out of 15, isn't it? 7 out of 15. Is that okay? Yes. Then picking a red is 3 out of 15. Then that is we are done with the first pick, isn't it? We go to the second pick. So if the first pick was green, it means the second pick can either be green again, red, blue, or if the first pick was blue, it means the second pick as well can either be green, blue, or are you seeing? If the first pick was red, it means the second pick can as well be either green, blue, or then you ask yourself, if the first pick was picked without replacement, if there were 15, if you remove 1 for the first time, meaning how many are left? 14, meaning for the second pick is just out of 14. Everything is out of 14 in the second pick. Are you seeing that? Without, because you pick and you don't replace. Are you seeing that? If the first pick there were 15 and you've removed 1, see only 14 are remaining. Yes. Are we together? So if the first pick was green, meaning only the number of greens have reduced, the rest have remained the way they were. Are you seeing? Yes. So if the first pick was green, it means blue remained the way they were, blue remained 7, red remained the way they were, red remained 3. So green has reduced by 1 because you picked it the first pick. Are you seeing that? Yes. Then you come here. If the first pick was blue, it means green and red have remained the way they were. Are you seeing? Meaning green are 5 the way they were, and red are 3 the way they were. So blue you picked for the first time, meaning only 6 blue are remaining out of the 14. Are you seeing? Are we together? If the first pick was red, how many are remaining? Red is only red which has reduced, isn't it? So it means green is remaining the way they were. Green are 5, isn't it? And red is what has reduced, isn't it? So red are remaining 2 out of 14. Then blue remains the way they were because the first pick was red. You see? So when you are saying when you pick 2, it means you picked green and green. Are you seeing? You picked green and green. If you pick 2, you picked blue and green. Are you seeing? Yes. You picked blue and blue. Are you seeing how many diagrams work? Yes. It represents whether they are independent or independent. Remember when you say 2 are picked at the same time, it's like saying 2 dice are thrown all together. You see? When you say 1 is picked at a time, it's like saying 1 dice is thrown twice, but when you represent it, comes out to be the same representation, okay? So what do we get here? The first here we have green, then here, green, blue, then here, green, red, then here, blue, green, then here, blue, blue, then here, blue, red, then here, red, green, isn't it? Then here, red, blue, then here, red, red. Then you start going to answer the question, isn't it? So remember we can remember when we were defining independent probabilities, isn't it? And is the multiplication law probability, meaning green and green. Both of them are green, isn't it? And green and blue. Then multiplication law probability and, isn't it? Then or the addition law probability or mutually exclusive events, isn't it? So from here you start. The two are of the same color. So for the two to be of the same color, both of them are green. Either both of them are green, or both of them are blue, or both of them are. So it means the two of them are the same color. Either this, or that, isn't it? So it is the probability for part A. Two of them are of the same color. It means it is probability that both of them are green, or addition law probability, isn't it? Or both of them are blue, or both of them are red. So what do you get? Green and green, that is multiplication law probability, isn't it? That is 5 over 15 times 4 over 14. 5 over 15 times 4 over 14. Then plus blue and blue you have 7 over 15 times 6 over 6 over 14. Then you move to the next one plus 3 over 15
times
2 over 15. What do you get? Calculator. Randy, what do you have?
I'm using one calculator, but it's not accurate.
You can see this the same denominator, so you just use some small common sense. You say this is 20 plus 42 is 62 plus 6 is 68. So you say 68 over 15 times 14. Here you have to be very sharp, isn't it? 14 times 15, you have 120, 150. This is 150 plus 60, 210. That is 68 over 210. What do we have? $68 over 210 is 34 over 105, isn't it? Very simple. You don't waste time with that, isn't it? 30 over 105. Then you move to part B. Are we together? You move to part B. So no red is picked. So you go where there is no R, isn't it? No red is anywhere you don't see R. Meaning it is either green and green, green and blue, or blue and green, or blue and blue. So all this with red you don't need, isn't it? Anything with red is not required, isn't it? So it is probability of either green and green or green and blue. There's no red here, there's no red here, there's no red there. All this other, there's no red here, so all this four, isn't it? Either this, or this, or this, or... Are we together? Then the third one, a blue and a green in that order. Meaning the first one must be a blue. Then the next one is a green. So it means blue must come first, followed by green. Are you seeing? Not that green, then blue. You see that is a green and a blue. Can it be green followed by blue? It's a green and a blue. Can it be a blue followed by green? That is a green and a blue. But they don't want that. They want in that order, meaning blue must come first. Are you seeing? Yes. Blue must first. So it means blue followed by green is only this, isn't it? So they want the probability of blue and the green. In that order, blue must come first. But getting a green and a blue is either this or this, isn't it? But they say in that order, blue must be first. Are we together? Good. So that is the multiplication law probability of mutually dependent events. So what do you get? B times G. 7 over 15 times 5 over 14, isn't it? So you get 6 over 1 over 6. Good. You get 1 over 6. So your blue is 7 over 15, your green is 5 over 14. You get 1 over 6. And you've worked on that problem thoroughly. You get all the marks as required. Are we together?